Okay, YouTube, in this video we're going to discuss the concept of a logarithmic function. In the future videos we'll talk about their graphs, but for now, really defining what a logarithm is. And so what we could start with is this. We say for all x values greater than 0 and a values greater than 0, in other words, x and a have to be positive things, also a doesn't equal 1, then we'd say that this thing that you see right here is a logarithmic function. So we have y equals, and you would read this as y equals log base a of x. And we would say that this is true if and only if this following definition follows, but we would say if and only if a to the y is equal to x. So the important things I want to point out here in terms of a logarithm are that they could be listed as a logarithm or they could be written as some exponential equation here. We can tell this is an exponential equation because we have a variable up here in the exponent. The deal here though is this. We say that in both instances a is the base of this expression. So a is the base of this exponential expression because it has an exponent y and it is its base. And also we say y equals log base a of x. This is also the base. So what we're going to be doing is learning how to rewrite from logarithmic form into exponential form, starting with the fact we have to recognize the base. Now here's the thing with the logarithm. What it's really asking is what could we take this little base to the power of to turn it into x? And actually it's being answered right here. Y is the power that I could take a to the power of to get x. So really this logarithm says a turns into x by taking it to the power of what? Well, this thing on the left. So over here on the right we have a turned into x by taking it to the power of y. And we say that these two statements are basically equivalent. So what I'm going to work on right here before we kind of get into what logs are asking for is to work on rewriting things from logarithmic form into exponential form and exponential form into logarithmic form. All the other things will fall into place once we can do this. So looking at this first statement here, basically what this is saying is log base 2 of 16 is 4. Or in other words, 2 to the power of what turns into 16. And so we always have this little base turning into this big number right here written larger by taking it to the power of this 4. So in exponential form we would say that this would be the equivalent of, now what's our base? 2. 2 turned into what? 2 turned into 16 by taking it to the power of what? To the power of this thing on the right. So 2 to the 4th power equals 16. We would say that these two equivalents, they mean the same things. So looking at this next one, we say, well, what's our base? Well, our base is 10. So to rewrite this into exponential form, we're saying 10 to the power of something here turned into what? Well, it turned into itself. So I bet you could think of what this would be already here, but we have it listed on the left here. We say it'd be 1. So 10 to the power of this thing over here turns it into this larger, more largely written number here. So looking at this next one, we say, what's our base? Rewrite this from logarithmic form into exponential form. Well, our base here appears to be 3, and 3 turned into, it looks like, 1. By taking it to the power of what? Well, the thing that we have listed over here that is the power we took it to must have been this 0 right here. So now these last two expressions, what I want you to notice is this. These are written in exponential notation. And if you want to, talk about how I know this, I would just say, well, there's no logarithm, so it's not a logarithmic expression. Plus I have a base to the power of something. Anytime you have an exponential expression, just like we rewrote our logarithmic expressions into exponential form, we can rewrite exponential expressions into a logarithmic form. So we would say that this would be the log. Now, here's what we're going to think. We're going to say, well, what's our base? The nice thing is the base of the exponential expression is the same as the base on our log. So we say log base 2. And what we're seeing here is that 2 turned into 16. So that's going to be the number we station here. So the question is, well, what could I take 2 to the power of to turn it into 16? And that answer, this 4 right here, is actually what we'll put on the right side. So what we can take 2 to the power of to get 16 is this 4. Likewise, over here we say our base is 5. And we say 5 turned into 1. So log base 5 of 1 is 0, but because 5 to the 0 power equals 1. So knowing how to rewrite these things actually is very, very useful when it comes to evaluating logarithms like the ones we have right here. Before we do that though, I do want to talk about some special properties of logs, and these are properties that show up all the time. So we say log base a of 1 equals what? Well, here's the thing. What we're saying is that we have some positive number that's not equal to 0 here, and we took it to the power of something and we got 1. So we say log base a of 1 is equal to 0 because a to the 0 equals 1. Now let's say I didn't know this yet. What could we have done? Well, one thing we could have done is just written a question mark here and said, well, how can I answer this? The key lies in that we will rewrite this into exponential form and it'll become a lot clearer. So I'd say a turned into 1 by taking it to the power of. Now think about this. What is it that we could raise something to the power of to get 1? And that answer is always going to be 0. So it is worth noting that the log base a of 1, anytime you take the log base a of 1 where a is a positive number, you're going to get 0 for your logarithmic value. So let's look at this now. We say log base a of a, and I'll put a question mark here. And we say, okay, well, what would this question mark have to be so that our log base a of a equals it? Here we say, but basically so that our base of a to the power of something has a turning into itself. And so we say, well, what can I take this to the power of? I would say 1. Just like up here I said 0, I say here I'd say 1. So this would be 1 here. So to answer log base a of a to the x power, let's rewrite this into exponential form. Our base is a, and a turned into a to the x power. So the question is, what could I raise this to get a to the x? And you'll notice that instantly we get just x. So log base a, which is a logarithmic thing, of a to the x, which is an exponential thing, if these have the same basis, we'll see eventually that those cancel out, and we just leave behind that exponent. But we'd say is x in this case. And log base a of x equals this, then this. Okay, so we're going to say if log base a of x equals y, like our function here, then we'd say a turned into y by taking it to the power of, sorry, got these backwards, a turned into x, didn't it? A turned into x by taking it to the power of y. Okay, so using this fact that we can rewrite it to different forms here, let's answer these following questions. We may not even need to rewrite it, but we'd say, what could I take 4 to the power of to get 16? Well, I obviously think it's 2 because 4 squared is 16, but rewriting this, we would have said our base is 4, and 4 turned into 16 by raising it to this power. Now I can more easily see that that would have to be a 2. Likewise, on this next one, we say log base 5 of 1. Well, I remember from up here, anytime we take the log of 1, we'll get 0. But again, let's talk about why. Because our base here is 5, we'll rewrite this into exponential notation. 5 to the power of something turns into 1. This must be a 0. Log base 4 of 2. Now this one's a little bit trickier. People, they're like, well, okay, well, we went backwards. We went from 4 to a smaller number. How does this work? Well, rewriting this, I would say 4 to the power of something turns this into 2. And so the interesting thing here is we're actually going to need to raise this to the 1/2 power. And the reason why is because recall that when you have, say, 4 to the 1/2 power, that is the same thing as 4 to the first power second root, or the square root of 4. Okay. So the important thing to note here is that sometimes we're going to get answers that are a fraction, and it's because we're taking the root of a number. Okay. And then last but not least, 3 to the power of what equals -1. I'm going to encourage you to always rewrite these. We say 3 to the power of what equals -1. I want you to consider this. Is it possible to raise a positive number to the power of something and get a negative result? And we would say here that there is no number that would cause this to happen. This does not exist, okay? So there is no value there. Cheers.